My dear students, like arithmetic progression, there is another progression which is called geometric progression. Let us understand geometric progression with the help of an example. I am writing a sequence that is 1, 2, 4, 8, 16, 32, 64, okay, and so on. So in this sequence, A1 is the first term, 2 is the second term, 4 third term, 8 fourth term, 16 is the fifth term of the sequence, 32 is the sixth term, and 64 is the seventh term of the sequence. Similarly, this form a geometric progression. Why it is geometric progression? Let's see. In this series, there is a common number multiplied to the previous number of this series. The first term is 1. If we multiply 1 first term by 2, we get second term. Again, if we multiply 2 by 2, we will get third term, 4. Similarly, if we multiply 4 by 2, again we get fourth term, that is 8. Again, if we multiply 8 by 2, we will get the fifth term of the sequence, that is 16. So throughout the sequence, we have seen that there is a common number which is multiplied to the previous number or previous term of the series, and it gives us successive terms of the series. So the common number here is called the common ratio. How we can say it as ratio? Let us say 2 divided by 1. Again, 4 divided by 2 give us 2 by 1. 8 divided by 4 give us 2 by 1. 16 divided by 8 also give us 2 by 1. 32 divided by 16 also give us 2 by 1. 64 divided by 32, again it is 2 by 1. So the common ratio, we can say common ratio in this sequence is 2 by 1, or the common number multiplied to the previous number is 2. So in this sequence, we have seen that there is a common ratio 2 by 1. So in this type of sequence where we get common ratio, then this type of sequence is called geometric progression. So it is named as geometric progression. So this geometric progression can be generalized as a geometric progression can be written in general order as A is the first term, AR is the second term where it is common ratio, AR squared, if we square common ratio and multiplied by first term, we will get third term of the sequence, AR cube, AR to the power 4, and so on. So on. For nth term of the series, we can write n minus 1. We have seen that for first order, there is no r, that means r to the power 0. Here, a r to the power 1 for second term. For third term, r to the power 2, that is 3 minus 2 equal 1. For fourth term, it is ar cube, 4 minus 1. Power is 4 minus 1. Similarly, for fifth term, ar to the power 4, here it is r, 5 minus 1. So we can understand that for n order of term, we have ar to the power n minus 1. So this is the formula of GP. So formula of GP is what? For nth term, we can write it as a r to the power n minus 1. Let us have more example of GP. Here 3, 6, 12, 24, 48, 96. So what is the first term of the series? It is 3. And what is the common ratio? It is 3 multiplied by 2, 6, 6 multiplied by 2, 12, 12 multiplied by 2, 24, like that. So it is, the common ratio is 2 by 1, that is 2. Okay. Another example of the sequence is 9, 3, 1, 1 by 3, 1 by 9, 1 by 27. First example is increasing order, but here it is in decreasing order. Let's say 9, 3. If we divide 9 by 3, we have 3. If we divide 3 by 1, we have 1 by 3. If we divide 1 by 3, then we have 1 by 9. Again, if we divide 1 by 9 by 3, we have 1 by 27. So here the common ratio is 1 by 3. As we are dividing, so it is r equal 1 by 3. And the first term of the sequence is 9. Similarly, in this sequence, first term is 8 and the common ratio is 1 by 4. That means when we divide 8 by 4, we will get 2. When we divide 2 by 4, we will get half. If we divide 1 half by 4, we have 1 by 8. Also, if we divide 1 by 8 by 4, we have 1 by 32. So these are the examples of geometric progression or geometric sequence. So if we are asked to find out the sum of the terms of a geometric progression or geometric series, we have to use this type of formula. I am writing here for n terms. N values may be vary from 1 to or 2 to any value. So if we are asked to first find out the sum of first n terms, then we will use this formula. So sum of n terms is equal to a, it is the first term of the sequence, r is the common ratio to the power n, as we are asked to find out n terms. So it is n minus 1 divided by r minus 1. This formula is applicable when common ratio is not equal to 1. If value of common ratio is equal to 1, then we will get total sum of n terms is equal to 0, and it is impossible to have 0 answer for fixed values. Therefore, this formula is applicable only for the condition r common ratio not equal to 1. For infinite terms, that means for large number of terms, we will use this type of expression. This expression, it is for n terms, n varies to infinite, so a divided by 1 minus r, when r value of r is less than 1, and if value of r is greater than 1 or equal to 1, then it is diverges. That means the value will be very large or it won't converges. It may be infinite. When r 1 minus 1 is equal to 0, any value divided by 0 is not defined. So it will be diverges. Therefore, this formula holds only when common ratio, value of common ratio is less than 1. Let us take example. The example which we have started in this discussion, that is 1, 2, 4, 8, 16, 32, 64. So these are the term first, second, third, fourth, fifth, sixth, seventh term of the sequence. So we are asked to find the sum of first two terms. First two terms. What are the first two terms? 1 and 2. we are asked to find out the sum of first two terms. That means 1 plus 2. Okay. So S2, two terms, is equal to A1 plus A2 equal 1 plus 2 equal 3. And also we are asked to find out four terms. Sum of four terms. What is sum of four terms? So we have to add A1 plus A2 plus A3, A4. So we will put directly here values 15. Okay. But we have this formula. Okay. We have this formula. We can use this formula. So using this formula, we can solve in this manner. So this can be solved by using formula A4, A r to the power 4. We are asked to find out the first four terms. So n is equal to 4. N is equal to 4. So r 4 to minus 1, r minus 1. In this sequence, the common ratio or common factor is 2. So value of r is equal to 2 and first term is 1. So we will put this value and we have answer. So this answer and this answer are same. So we can add in this manner also, or using this formula we can solve, we will get the same answers. There can be another question for same example. Here we are asked to find the sum from third term to the seventh term of the sequence. That means we have to find out from A3 to A7 term of the sequence. So we will start here from A3, A4, A5, A6, A7, like that. Okay, so third term is A3, seventh term is A7. So putting the values of all the terms, we have 124. Or we can use this formula to find out the sum of third term from third term to the seventh term of the sequence. Here we are writing S7. That means sum of all the 7 terms minus sum of 2 terms. We are not writing S3 because we have to include the sum of third term. Here we are including third term because we are asked to find out sum from third term to the seventh term. So we cannot write this S3 because if we write S7 minus S3, then the third term value will get excluded. So we have to exclude the sum of first 2 terms only. Therefore we are writing S7 minus S2. So putting the using this formula, we can solve this problem and we have this answer. Some real life examples are such as the GP is used in banking, that means in compounding interest for loan or for saving accounts. In case of growth of population size forms a geometric progression. Decay of radioactive material or decay of nuclear material follows geometric progression. Also, gradually decreasing height of a bouncing ball also follows geometric progression. There are many more examples of geometric progression, but these are the common examples of very common examples of geometric sequences or geometric progression.